So we're going to take a look at continuously compounding interest, and this has a different looking formula. This formula introduces for the first time a number called E. Now, E is a number that is about 2.718. We're not going to get into in this class where that number comes from, but continuously compounding interest is as if we took our regular compound interest formula and used an infinite number of compounds. As to why the formula changes from the regular compound interest to continuously compounding interest, this P times E to the RT, we're not really going to get into that in Algebra 2 trig this year. However, we do need to know how to use this formula. So the first thing you want to do is try and locate the E button on your calculator. It will either look like the letter E, or often it looks like E to the X. It's usually pretty close to the LN button, if you can find that. So, for example, if you have a TI Inspire calculator, the E button is located kind of by where your left thumb goes. Right here, you see it says E to the X. So if I want to know what E squared is, for example, I would say E, and then it brings me up a power, so E to the second power. And since E is just a number squared is going to give you just some other number, okay? If you need to pause to write down this formula, go ahead and do that. The continuously compounding interest formula is often referred to by shorthand as A PERT, just like the shampoo. So the difference between regular compound interest and continuously compounding interest is that there's actually less to do. So we would say what our principal value is. In this problem it's 1,500. E is just a number, but we write it down as E the letter anyways. And then we are going to write down the rate as a decimal times the number of years. Now we would punch this into the calculator, and that would give us a value. I'm going to pull the calculator up, and you're going to have a chance to see how that would work. So go ahead and try and punch that into your calculator if you were able to locate E on the calculator. So when you plug it into your calculator, make sure you use the E button. You may not be able to tell, but I tried this a couple times before realizing that I actually had to use the E button on the calculator. And it kept returning the answer that you see over there a couple times where it didn't do anything for me, and that was very frustrating. So make sure you use the E button. The number that we get is $1,616.83. So see if you can do that yourself for after 5 years. Try and figure out what changes in between the first problem and the second problem. Okay, I'm going to write down the answers. So if you haven't figured it out, you probably want to pause. 1,500 times E to the 0.075 times 5. And let's go to the calculator to see what that would give us. Here's a little fun fact. If you're using one of these new calculators, you can highlight what you previously entered and hit enter, and that will give you the chance to kind of edit what you have instead of reinventing the wheel here. So if we change the 1 to a 5, we get that we are at $2,182.49. That's a lot of money. So our final answer would be 2,182.49. Remember, a lot of the questions on the test are going to require you to double something or figure out how you have how long you need to have a certain amount of money. Until we learn how to solve these, we are going to be guessing and checking a lot. So do your best on that. I'll see you when I see you. And here's the homework.